Good morning, Michael. What are we up to today?
Well, we've been talking about trig functions, sines and cosines, and we figured out the derivative of sine at 0, which was 1. We should ask the question, what's the derivative of cosine? Would you like to see that?
Absolutely. Let's start with a bit of geometry.
Okay, so let's do a bit of geometry. Remember that sines and cosines are coming from a circle. So we've got this equation that the cosine of some number x squared plus the sine of that number squared is 1, because that's a circle, right?
That's our famous circle, right?
Now, with a little bit of algebra, we can say, well, I can write down a formula for cosine. Let's not worry about pluses and minuses, but this would be the square root of, here we have a 1, subtract off the sine squared.
Okay, so maybe we can use this in our differentiation of cosine since we know what sine is doing.
That's right. So we've got cosine here. This is a number, a 1 minus sine squared of x. It's a number smaller than 1. What do you know about a number when you take its square root? It does get bigger or smaller?
It gets bigger when you square root it.
That's right. It's kind of funny thing that a smaller number between 0 and 1, when you square root it, gets bigger. So this thing has to be bigger than the thing before we take the square root, right?
Yep. And how's that related to x when x is small?
Well, remember we showed that for x small, sine of x was always smaller than x. So if I subtract off something smaller off of 1, it's going to be bigger than what I get if I subtract off something bigger.
Yeah,
Right?
so 1 minus sine squared x is greater than 1 minus x squared, right?
And so remember we started off with cosine of x. So we get cosine of x is bigger than 1 minus
Oh,
x.
yes.
But we also know 1 is bigger than cosine of x, because the cosine never gets bigger than 1.
Yeah, geometrically.
So here I drew a little pitch, 'cause I was thinking ahead. Here's the y equal 1 curve, which is this guy here, the 1. And here's the 1 minus x squared, which is this curve here. That tells us cosine, whatever it does, okay, maybe it's a crazy function, it's not, but it means it has to squeeze between these two things.
Oh, yeah.
So that's what cosine of x has to look at. So what does that tell us about the best line, straight line approximation to the curve at this point?
Well, it's flat.
It's flat. So what's the slope of a flat line?
0.
That tells us that the derivative of the cosine is 0 at x equals 0.
So derivative of cosine is 0 at x equals 0, and derivative of sine is 1 at x equals 0. And so we've only got things in the neighborhood of 0, but we want to know what it might be for a general sine and cosine, not just near 0.
Right. So the way we can do that is use our trig formulas or addition formulas. So I'm going to throw up a magic formula for you. Can we pause here and erase this screen and then pick up the
Or
recording?
we could talk while we're erasing.
We could
let's
do that.
That's more fun. How about some water?
Maybe we'll put a little water on them.
I'll do some too. What's that?
Oh, you can leave that up if you like.
I can leave that up? Okay. Well, this
So what
is
I'm going to do is, we know a bunch of trig formulas, and let's not worry too much about where the trig formula comes from. We could talk about that another time. But here's a very famous trig formula. If you take the sine of an x, let's say x0 plus x, because we want to figure out what the derivative is at a different place. This is sine of x0 times cosine of what?
cosine of x.
Right. And I add to it
Cosine. Cosine sine.
and sine of x.
And x is small in this case.
X is small. So x is small. So we know from the derivatives, if x is small, sine x is approximately equal to?
1. For derivative of sine near x small is going to be 1.
Well, that tells me the line is slope 1.
Yeah.
So a line of slope 1 is 1 times x.
Right.
So this guy is going to be approximately equal to x.
Sure.
Okay. Now, I think you might have been thinking cosine. Cosine is close to 1.
1.
So I can write it as 1 plus 0 times x, so it looks like a line.
Okay, with the slope of 0, which is flat, which is what we got earlier.
So if I write this out, I get sine of x0 times 1 plus x plus 0x plus cosine of x0 times x.
Okay,
So the zeros I can ignore. The sine of x0 is like this. So I get sine of x0 plus x minus sine of x0 is just this little part. So sine of x0, we'll write it the way we wrote it earlier. The difference of the function at two places is approximately this guy. Now that looks like a line.
with slope.
There's our slope.
And as they say in England, Bob's your uncle.
Bob's your uncle. So what does that tell us about sine? The derivative of sine at x0 is going to be?
Cosine of x0.
That's right. Let's write that down. Derivative of sine at x0 is cosine of x0.
That's at any x0, right?
At any x0, yep. So that works for any real number x0 that you want. That's what we want to learn today.
Fantastic. I still like to know where this comes from, but I think we are going to talk about it a little later on, right?
In another video. Let's do that,
Let's
Matt.
do that.